Okay, so now we are going to discuss example 1, part C. All right. Okay. Now, for part C, I will consider it as a second pattern of the modulus function. Okay, just now we discussed part A, right? Okay, so for part A, the question is x minus 2 modulus equals to 3. Part B also the same. Part B, you are having modulus 7 minus 2x equals to 2. Okay, so this one usually I will call as pattern number 1. So pattern number 1 is that you have one side modulus function, the other side of the equation is a number. So this one we call as pattern number 1. So for pattern number 1, we are using non-modulus form to solve it. To me, that is the easiest method. Okay, and then for C and D, I usually call as second pattern, pattern number 2. Okay, so how I look at this pattern, it is one side got modulus, the other side is a function. You compare A and C. Okay? Both also got one side modulus function. But for part A, the other side is number only. And then for part C and D, the other side, no modulus, but it is a function, 3x, got x1. Okay? A and B are only numbers. So this one got x1. Okay, so this one usually I call it as pattern number 2. Alright? So for pattern number 2, the best method to use also a bit different from part A and B. Alright, okay, so I will show you now. Okay, so please make sure that you know what is pattern number 1 and pattern number 2. Okay, then maybe you can discuss part 3 also, part E and F. Okay, pattern number 3 we call as this one, pattern number 3, part E and F. So pattern number 3 is both sides you also got modulus function. Alright, so we call it as pattern 3. Okay, so we have pattern number 1, number 2, and number 3 in short. Okay, so we already discussed pattern number 1 just now, where we are using the non-modulus form to solve the equation. To me, that is the easiest and also the easiest method, the best method. Okay, then what is the best method or what's the easiest method for C and D? So again, I will solve part C for you. Then you try part D yourself. Okay. All right. So let us start. Okay, so for part C, so again, if let's say I want to use graph method, method number 1 to solve the equation. Okay, so how can I solve it? So first, to sketch the graph, you need to sketch two graphs here. The first one is modulus 2x minus 1. Okay, the other one is you need to sketch 3x. Alright, so for 2x minus 1, when x equals to 0, your y is 1. Oh, sorry, you have to draw the original point first, right? Okay, so that means when x equals to 0, y equals to negative 1. Okay, and then when when y equals to 0, so your x is equals to half. Okay, then for this one, you can use that when x equals to 0, y also equals to 0. Alright, so maybe you want to use another point, maybe when your x equals to 1, then your y is equals to 3, let's say. Okay, alright, then maybe now from now you can start to sketch the graph. Okay, so for me, if I want to get a good graph, generally I will try to use graph paper so that you can see very clearly what do I have. Yeah, alright, so in exam again, all these points you don't need to show. Okay, so I will label this as 2, this is 4, same thing happened here, 2, this is 4, this is negative 2, negative 4, this is 2 and 4. Okay, alright, so first point, 0 and negative 1. So 0 is here, negative 1 should be this part, this point. Okay, and then you're having 0, x equals to half, y equals to 0. So if this is 1, then I can only approximate to draw it out. So maybe this is half, x equals to half. Alright, so I need to sketch a graph. Okay, so this is my graph here. But if I want to put modulus to 2x minus 1, that means you need to reflect your graph out. So to reflect your graph out, the y-intercept originally is negative 1, you reflect out become positive 1. So this is positive 1. and when you divide it up, it will look something like this. Okay. All right. So this is what I have for my modulus 2x minus 1. So again, the green color part means the reflected graph. Okay. All right. Then after that, they want you to sketch y equals to 3x. So y equals to 3x means that pass through 3 and 0. Sorry, not nice. Okay, so pass through 0, 0, and then pass through 1 and 3. So 1 is here, 3 is this one. Okay, then you can try to sketch it out. Okay, all right, so this is the graph that I have. Of course, if you want, you still can label it out clearly. So this line is y equals to 3x. No need to reflect the graph because there's no modulus sign. So y equals to 3x means this whole line. Okay, and then for the modulus function, this one is original one. So y equals to 2x minus 1. And also the green color part is y equals to 1 minus 2x. You put a negative in front, so it will become 1 minus 2x. Okay, so the V shape is actually the modulus function. The 3x is actually this straight line here. Okay, then now you are looking for the intersection point when you want to solve the equation. So where's the intersection point? This one. So if you look at this intersection point, it is actually the intersection point between y equals to 3x and also y equals to 1 minus 2x. So you have 3x equals to 1 minus 2x. Okay, so you're having 5x here, so 5x equals to 1, and therefore your x is equals to 1 over 5. Which is still logic if you look at the graph. Okay, so you have only one intersection point can be seen here. Is there any other intersection point here or not? So if your graph, you draw it in a proper scale, you will see that these two lines, right, they won't intersect at each other anymore because they are going apart from each other. All right, so they won't come back and intersect with each other anymore. All right, so from here, from this graph, you will see that there's only one intersection point. So here, there's no intersection point anymore. All right, so therefore, when you solve it, you can only get one answer, which is x equals to 1 over 5. Okay, all right, so this is what we have for method number 1. If I want to use a graph and solve it. Okay, so from the graph, you can see very clearly that you have only one intersection point. So that's the advantage for the graph here, because if you draw in a really good scale, very proper scale and everything, right? So your graph can show you very clearly how many answers do you have. So here you have only one intersection point, therefore you have only one answer. All right. Okay. So this is method number 1. Okay. And now, how about if we proceed to method number 2? Okay, so for method number 2, I want to use the non-modulus form to solve it. Okay, so again, y equals to modulus 2x minus 1, right? I can rewrite it become 2x minus 1 and also 1 minus 2x. Okay, so for 2x minus 1, it is actually for x greater equals to 1 over 2. And then for this one is x smaller than 1 over 2. So the same thing happens here. When you want to solve the equation here, you will let 2x minus 1 equals to 3x. Another part is 1 minus 2x equals to 3x. Okay, then you need to try and solve it. So when you want to try and solve it, right, so you have negative 1 equals to x. Okay, then for this one you have 5x equals to 1 and x equals to 1 over 5. Alright, so now here we have some problem already. Okay, because from the method number 1, we only get one answer. But if we are using this method, we have two answers here actually. Okay, alright, so how can I decide which one is the correct answer? Okay, so for this second part, you need to check, okay, which is the correct answer that you want to accept. Okay, so when x equals to negative 1, you put it into the left side equation. What is the left hand side equation? Modulus 2x minus 1, right? Okay, so when you put x equals to -1 here, -1 times 2, you get -2, minus 1 is -3, modulus, you get a 3. But if right hand side, when you put in the x equals to -1 into the equation, you will have -3. So do you see that these two, left hand side and right hand side, having the same value or not? No. So that means they are not intersect at x equals to -1. Alright, so therefore, this is the answer that you want to ignore. Okay? Alright, and then after that, you also need to check for x equals to -5. So x equals to, 1/5. Okay, then you can check left hand side. When you put it into the left hand side equation, okay, so you're having 2/5 minus 1. You get -3/5 modulus, so you get 3/5. Then the right hand side is what? Again, you are having 3x, right? So you put 3 times 1/5, you get 3/5 also. So for this particular value, you'll see the left hand side and right hand side have the same value here, and therefore x equals to 1/5 will be the correct answer. Okay, all right. So this is how we do it for method number 2. Okay, so some students will say, just now by using method number 2, do I need to check the answer or not? No need. In the first part, in the pattern number 1. So for this second pattern, when you want to use method number 2, you have to check the answer. Only for pattern number 2. When one side got modulus, the other side has no modulus function. No x punya modulus. Okay? No modulus punya function x. Right? So you have to double check. So this particular part in the exam, no need to write up. It is for your understanding here, but in the exam, you still need to check it on your own. But you no need to show them. Okay, and then in the exam, you have to tell them that you ignore this answer because this is not the correct answer. Alright, okay. So this green color part is to teach you how to ignore the x equals to -1. But in the exam, you don't need to show them because they won't give any extra marks for this. Okay, so this is what we have for method number 2. Okay, then now we can proceed to method number 3. Then later on I tell you which is the method I usually use. Okay, so for method number 3, square both sides, right? Okay, so for method number 3, when you want to square both sides, it is the same thing also. You are having 2x minus 1 equals to 3x. So when you square both sides, it will become 2x minus 1 squared. The modulus disappear, and then you are having 3x, and then you square. Okay, so for x squared minus 4x plus 1 equals to 9x squared. Then if you continue further, you are having 5x squared plus 4x minus 1 equals to 0. And after that, you can try to factorize it. Okay, so for this one, I should have a plus. Is it I should have a plus here? Wait, okay, so I should have a plus here. This one is a negative. Okay, so when you solve it, you're having x equals to 1/5 and also x equals to -1. So again, alright, so for this particular method and also for this particular pattern, you are getting two answers here. Therefore, again, you have to check. So the same method applies. So you check for x equals to -1. So left hand side again, already show you just now, you get a 3. Right hand side, you also get a -3. Therefore, for x equals to -1, you need to ignore it because left hand side and right hand side didn't have the same answer. Okay. Then when x equals to 1/5, you will check that left hand side is equals to 3/5. Right hand side is also 3/5. Okay. So for this one, that means x equals to 1/5 will be the answer. Okay. Alright, so now for this particular pattern of the question for part C, you're having method 1, 2, and 3. So from here, you will see that actually method number 1 here is not too bad for you to apply. Although you need to draw the graph, but the graph can show you very clearly how many intersection points you have, and your solution here is quite short. But of course, you need to draw the graph. Okay, then the solution here is something like this. This is method number 1. Method number 2, actually it's not very hard also. The only harder part is checking. Okay? And then for method number 3 also, when you square both sides, you also can get 2 answers, and then you still need to continue with checking. So only method number 1 no need to check. Okay, so for this one, again, in exam, as what I said, you can still use any method that you like. Okay, but usually for me, in exam, right, most of the time, I'm using 3. Okay, but actually method number 2 is also not bad because method number 2, you know, no need to how to say, solve quadratic equation. It is all linear. So you can use either method number 2 or either you can use method number 3. Usually for exam, I will not draw graph because to me draw graph is a bit wasting time. All right, but again, this is a good method because you can see the graph very clearly and you will know roughly how many intersection point you have. Okay, then you don't need to verify your answer. But 2 and 3 you have to verify. Okay, so when do you need to verify the answer? Again, when you are having the equation with one side modulus and then the other side no modulus, but it has the x. So for this kind of pattern, whenever you want to apply method 2 and 3, you have to check your final answer. You have to. Okay, so this is what we have for our second pattern of the question. Okay, so I hope that you roughly have the idea. Alright, then now for part D, you have to complete it yourself. Part D, what is the question here? So again, it is modulus x minus 2 equals to 2x plus 5. So you can see that one side got modulus, the other side have no modulus, but with the x inside. Alright, so it is quite similar with part C, second pattern. Okay, so again, if you are free, try to use all the 3 methods to solve this one, to train and practice all the basic skills for modulus function and modulus graph first. Okay, so for part D, if you do it correctly, you will get only one answer. So the answer should be x equals to -1. Only one answer for this particular question. Okay, all right. So make sure you try it out. If can, it will be the best if you try all the 3 methods. Alright, okay, so this is what we have for the second pattern. Then for the next video, only we're going to discuss the third pattern of the question. Okay.